Good evening. It is 5 o'clock Eastern Time, 2200 UTC. Welcome to Ten-Tec Television. I am Scott Robbins, W4PA. I am the Amateur Radio Product Manager for Ten-Tec Incorporated, and we are here in the Visitors Ham Shack in Sevierville. Today we are going to do a presentation on the Model 238B antenna tuner. The 238B is an L network tuner. This is a tuner that we have had out for quite some time now. Originally it was a Model 229 that we had out with the original Omnis. It later evolved into the 238, 238A, and 238B. What all of these tuners have in common is that they are all the same L network circuit with some changes for inductor, indicator, how the antennas are switched, but essentially the circuit among all of those tuners all these years has been the same. Its present form is Model 238B. Let's see if we can get a shot of that on the camera. Let's see, a front panel view would be good. Okay, this is the front panel view of the 238B. We have a meter up at upper left. This knob right here is SWR set, 200 watt and 2000 watt scales. This is an SWR calibration knob. A single variable capacitor, a single variable inductor. This knob in the center is either used for bypass or to reverse the L network, and I'll explain that a little bit more. This over here is a 4-position antenna switch. You can put 4 antennas onto the 238B. You can have up to 4 coax fed antennas, or you can use position number 4 for a balanced line feed. Let's see, we'll have a shot of the top of this thing. I've got the top taken off the tuner. And here on the top, you can see back here at the back, this is a 4-to-1 balun. There are wing nut connectors here on the back for connecting either a single wire antenna or balance line directly to the back of the tuner. Okay, what I'm going to do is talk a little bit about the L network, and then we're going to put this thing on the air and I'll show you how it is tuned up. What is different about this tuner as compared to other tuners is this is an L network tuner. An L network, the principal obvious difference is that we're using a single variable capacitor and a roller inductor together, as opposed to typically a roller inductor and a couple of variable capacitors with a pi or an L, or perhaps maybe fixed inductance that's switched with a switch that has taps on a coil. The L network differs from the pi and the L for a number of reasons. It has several advantages over other configurations. Because it only has 2 adjustable parts, an inductor and a capacitor, there is basically, you're only going to have the best match for this tuner using the L and the C combination, because there's only going to be one possible combination of the 2 that will provide a match. The T network and the pi network tuner will certainly provide you with a 1-to-1 or reasonably close SWR when you tune it. However, those tuners can give you a false resonance. Essentially, you can present a 1-to-1 50 ohm load to the transmitter that isn't the most efficient use of transferring transmitter power out to the antenna. The L network assures that you will transfer most of the transmitter power from the transmitter or the amplifier out to your antennas. There was a survey article that was done in QST, February of 2003, that discussed various manual antenna tuners. And what I will do here is read an excerpt from that, from the ARRL article. This is February 2003. This, if you're an ARRL member, you can go to their website and you can read the entire article on their webpage. Let's see, the 238 is the only tuner in the roundup to utilize an L network. Using an innovative switching arrangement, the 238 actually provides 5 different circuit configurations to maximize efficiency. A look at the low loss figures in the table confirms this. There is a table here that basically measures amount of insertion loss when this tuner was tuned on various ham bands using a couple of different test antennas. One was a G5RV, and I think the other might have been a vertical. Let's see. This well-constructed tuner makes use of a single variable capacitor and a smooth-turning wire-wound roller inductor to match impedances of up to 3,000 ohms. Additional capacitance is switched into the circuit by means of a front panel switch, which is the bypass switch. We'll get a shot of this here on the front. Let me explain what that means actually while we're on this with the bypass switch. Bypass obviously is transferring antenna power directly to the antenna without actually employing the use of the tuner. Move this camera over a little. One of the reasons an L network hasn't had wider use in ham radio in the past or by other people is that the L and C components have to be reversed to put the capacitor across the input or the output, depending upon whether or not the load being matched is above or below 50 ohms. Essentially, that's what the function of this switch is here. It's labeled low Z, high Z. You can use this knob to switch in a little bit of stray capacitance if needed, which is particularly needed if you are matching a load that is close to resonance already. If you have something that's, you know, a 1.5 to 1 or a 2 to 1 SWR to start with, you may need to add a little bit of extra capacitance with the bypass switch, along with reversing the capacitor against the load or the output to make a match of 1 to 1 or close to 1 to 1. Okay, back to this the article here. Let's see. 5 settings are available for high and low impedances, which we discussed. A ceramic feed-through post on the back panel provides a connection to add an additional 1000 PF capacitor to the circuit for matching 160 meter antennas. And that is particularly used if you're using a shortened whip antenna or something like that on 160. It's very low impedance, for example. The small dual-use meter on the front can be used to display SWR RF power in a 2000 or 200 watt range. The meter lamp you see here is powered by a 12-volt jack on the back panel. Now, at the present, I don't have this lit up, and the reason for that is as I was playing with the video cameras, having it lit up, it's so bright that you can't read anything on the meter. So I will do a close-up on this. You can see that without the lighting, you can read the meter. Well, the camera would focus a little bit better, that is. With the light on, all of that is washed out, unfortunately. Okay, so now here is the key statement that Laurel made here. The 238 handily matched all bands on both test antennas at full legal limit power. And we were also the lowest loss insertion of any of the tuners that they had tested on all bands as well. Okay, so what we will do here is give you a little bit of an example of how this antenna tuner is tuned. What we will do is kind of, I'm going to start with the inductor down at the low end of the range at 0. So we'll flip over to the overhead camera. You can see that there's a wiper. That wiper is now moving across the screen from left to right, and I will back it down so we have the inductance at minimum. And I'm going to set the capacitor. You can see me turning here to some random point, put this on bypass. Okay, so what I'm going to do is we'll switch over to the front panel view of the 238. And I will, I've got the Orion 2 sitting here next to it, and I will transmit into it. And let's see, what I will do is I'll show the, see if I can show the meter here as I'm doing this. Or let's see. Bear with me just a second. Okay, so we've got the rig turned on. We are on 7.2 megahertz, and you can hear lovely foreign broadcasts in the background. So hopefully they won't mind us transmitting for a second on top of them. I've got a keyer here. Now this is on bypass. The antenna we are tuning here on 7.2 megahertz is a G5RV that is out strung off the tower in the front yard here at Ten-Tec. So I'm transmitting, you know, our SWR is somewhere north of 3 to 1. Okay, not good. That's not what we want. So what I'm going to do here is, to show a shot of the front panel, I'm going to turn these 2 knobs in an effort to get the SWR to come down. So I will start off by putting this maybe on bypass 1, and we'll give it a little bit of a, you can see on the meter here that it is still kind of high. We're going to go over here to number 2, and it's still kind of high, number 3. Okay, now let's see if we can maybe bring this down by turning the inductor a little bit. We're going to, there we go, we're moving the inductor down. Okay, so now we're doing a little bit better. Maybe 1.3 to 1. I'm going to move the variable capacitor, and look at this. That took almost no effort at all to get that down to a 1-to-1 SWR. Switch us over to 200 watt scale. You can see we got some power there, 100 watts out. Okay. Okay, now one of the things also that's advantageous for using the, let's see, over here. I'm going to change cameras here real quick.